So far we've looked at two types of transformations. Adding and subtracting inside or outside the function, which produces a translation or a shift in the graph, or multiplying or multiplying inside or outside the function, which produces a stretch or shrink in the graph. We also recall that anything done outside the function affects the y variable, and anything done inside the function affects the x direction. So once again, we're going to be looking at our parent function, f of x equals the square root of x. And we're going to be applying this translation where we multiply, or transformation where we multiply outside the function. So g of x then is the opposite of f of x, or the opposite of the square root of x. So let's take a look at a table of values. We know that in the original function, if I put a negative number into the function, I get something undefined, and then I would have the points 0, 0, 1, 1, and 4, 2, as shown on the graph. Now what if I put the negative sign outside the function? So first of all, I want to clear up something that some of you may be thinking. You may be thinking that the square root of negative x is equal to say for example, negative the square root of negative 4 is the square root of positive 4. That is not true. You would still have the square root of negative 4 is an imaginary number, and it would just be the opposite of that imaginary number. But you cannot distribute a negative sign over a square root sign. You can distribute negative signs over parentheses, but not square root signs. So let me just first of all clear that up in case any of you were thinking that. All right, so let's take a look. So if we have an undefined, actually I should say not undefined, but non-real number. These should be non-real rather than undefined, but they're undefined in the real number system. This is still non-real. Okay, so we're going to get a non-real number here or here. Okay, so those are still going to be non-real. Now, if I put in 0 for x, I'm going to get 0 for y. The opposite of 0 is still 0. So that point is still on the graph of negative f of x. If I put 1 in, and I would get negative 1 out now instead of positive 1. If I put 4 in, I would get negative 2 out because I'm taking the opposite of the function after I've computed y. So that means what the reflection would look like is it would go through the point 0, 0 still, but then it would go through the point 1, sorry, that's the wrong spot. It would go through the point 1, negative 1, and the point 4, negative 2. So this is what the graph of g of x would look like. It flips upside down or reflects across the x-axis. So notice this is a vertical reflection. A vertical reflection across the x-axis. Okay, so across the x-axis. Okay, so I'm guessing that you'll probably figure out this one pretty easily. If I make h of x my translation of f of x, where I put change the argument or the input of the function to a negative x instead of a positive x, then I could say h of x is equal to the square root of negative x. You might say, well, that's never going to be true because I can't take the square root of a negative number. But remember, negative x is not a negative number. It is the opposite of x. So if x is a negative number to start with, and I take the opposite of it, then I can take the square root, because then I'll be taking the square root of a positive number. So, for example, if x is negative 4, the opposite of x would be 4. So this would end up being the square root of 4, which is 2. So the point negative 4, 2 is a point on this new graph. If x is negative 1 and I take the opposite of negative 1, I'd be taking the square root of 1, which is 1. Oh, didn't turn out well there, so let me try that again. So I would have the point negative 1, positive 1. Now if I put in 0, I'm still going to get 0 because the opposite of 0 is still 0. But if I put in 1 for x, then I'd be doing the square root of -1, and I'm going to just put NR for non-real. I'll just put I'll write non-real. Sorry, I'm using this at home and it doesn't write very well. Square root of -4, also non-real. So those two would be non-real numbers. So my graph, instead of going to the right, would go to the left. So this would be the graph of h of x. So notice this is a horizontal reflection across the y-axis. So that's basically what a reflection is. Not very difficult. So in the first one, all the y values change sign. In the second one, all the x values change signs. Now, one last one is the absolute value, and it's kind of similar to a reflection, only partial. So let's say we want to take the absolute value of the entire function. So if that's my transformation, I would then write this as the absolute value of the cube root of x. So that means I would be taking the cube root of x first, and then taking the absolute value of whatever that y value was, whatever the output was. Excuse me. So, if we go to the table of values, you see the points that I've already plotted for this graph. Now, if we take the absolute value of f of x, that would be the absolute value of -8, which would be 8. And the absolute value of -1 would be 1. The absolute value of 0 is 0. The absolute value of 1 is 1, and the absolute value of 2, you know what, I think I have these backwards. This is not a correct table. Okay, I switched these around. This should be -8, -2. This would be the absolute value of -2, which is 2. And this should be 8, 2. Okay, so anyway, this would be the absolute value of -1, which is 1. This would be the absolute value of 0, which is 0. And these would stay 1 and 2 because I'm taking the absolute value of a positive number, so they stay positive. So some of the points don't change. The points that don't change are the points where y is already positive, because when you take the absolute value of a positive number, it doesn't change. But the points where the y is negative, which would be this entire section of the graph down here, would change. So instead of -1, -1, I'd have -1, +1. Instead of -8, -2, I'd have -8, +2. And the graph would look like this. And this section of the graph would disappear. So this section of the graph would flip up. This stays the same because y is already positive. So it's kind of a partial reflection. It reflects only the negative y values. The positive y values stay the same. So that's what an absolute value reflection, type of reflection does.